everyone, welcome back to this session. So in the previous session, we observed the deletion of elements, and as you can see the code that first pre-order traversal, we saw the elements being printed in the pre-order traversal, and then after the pre-order traversal, we deleted the elements, as you can see after deleting, and then we again printed the element in pre-order traversal. So we printed the element utilizing the pre-order traversal, but we didn't understand. So in today's session, we'll be understanding the pre-order traversal, that how the traversal was made among the tree and how it printed the data. So let's understand it without wasting the time. Okay. So there are actually three types of traversal: pre-order traversal, post-order traversal, and in-order traversal. So in terms of other language, sometimes we call it prefix, infix, and suffix. So this pre-order is called prefix. This is called prefix traversal. And the in-order, this is called infix, and this post-order, this is also called suffix. So if you have studied the stack, you will be knowing this prefix, infix, and suffix type of things. So how this pre-order works, let's take a tree. Let's take the tree from previous example. The tree is quite okay. Let's copy it back. 50, 30, 70. Okay, we will just take another any tree like simple. So that is 50, and then that is 30, 70, 20, 40, 35, 18. So we have just any type of tree. So we'll be traversing the tree. So there are various strategies how we can traverse the tree. First one, the pre-order. So pre-order is like this. The pre-order traversal. Pre-order. If you understand the term pre means first. So the normal infinix is like this. First there is the left side. This is the left portion. Left. And now there is the root, and after the root there is the right. This side is the right, and this is general pictorial representation, and this is called in order or in fixed representation. So what did you understand from here? That in fixed or in order, this representation is like this: left, first there will be left, then there will be root, and then there will be right. So this is in fixed or in order traversal. That is in fixed or in order traversal. So now note, observe, this is in order. So if we just bring the pre that means first, if we just bring it in that side, the new rotation will be like this: root, root, left, and right. Now notice one thing, that the root came in the previous position. And that's why this type of rotation, we call this rotation as the pre-order rotation. So this type of orientation is called pre-order traversal. Okay. And if this root is brought at the last, that means at the post position. So the new rotation from here, it becomes like this: left, first there will be left, then there will be right, and the root comes at the post position, and this is the root. So root is at the last position or post position. So this type of orientation is called post order traversal. So this is in order, pre-order, post order. So let's understand. So in today's video, we'll again recap of in order, pre-order, and post order. In order traversal. In order traversal. In order traversal is general traversal, where first this is tree, this is left side, this is the root, and this is the right side. And here the tree is having nodes. So this is infix representation, general representation. So from diagram we can easily understand that in order is having this structure. First there will be left, and then there will be root, and after the root there will be again right. So this is infix representation. In prefix, what is becomes that the root, this root comes in the front, and that becomes the prefix, pre-order traversal, pre-order or prefix. So this is the root, root, and then left, and then right, and then right. The root came in the forward position. The root came in the forward position. And in the post order, the root moves back to the post position. In post order, the root moves back to the post position. So the orientation would be like this: left, left, then right, left, right, and then the root will come at the post position. So this is the general recap, that in the post order the root is in the post position, in pre-order this is in the first position, pre-position, and in order that is generalization. So this general representation the tree is having, this is in order or in phase representation or in phase representation. So okay, we understood this one. This is very easy. Now today we'll be understanding the main coding session, that how we can represent any tree in order. So let's take the in order. Let's take the tree. Again, we're taking this normal tree as we want from our mind. This one, 50, 50, and then this 50 is having child. So this is having 30, and this is having 70. And this 30, this is having 20, and this is having 40. And this 70, this element is having 100, and this element is having 60. So now if you want to traverse this element, if you just want to traverse an element in order, so this is this one you can see in order. So we'll be arranging the elements like this. First we'll just take array in order, in order. So we are arranging the elements in order. So as per the rules, what is said, that we first have to insert the left. That means this is this is our first element, and the left side we have to insert. So if we just insert 30 like this, we inserted 30 left side, then we have to insert root 50, and then we have to insert it 70. So if we just follow this orientation, will it be right? No, it will not be right, it will be directly wrong, because we have to think in terms of program, because it actually works in terms of program. So let's understand, let's think like a programmer. Okay, so when we have to follow this system, this general system, but in programming manner, when it comes here, when we are here, we see that this is the root, this is the entry of the program. So we come in the left section to traverse. Now when we come in that section, in that position, that this is left with respect to this, with respect to that this is left, and when we come here we see that this becomes the new root, that becomes the new root. You got to understand, it becomes the new root. So now this is the left, that is the left, and if you see again with respect to this section, so this is null, this is null, so there is nothing. So now we can understand that with respect to that, that is the null position, that is this. So this first will be just putting this left part first. So left, this is 20. So the in order will be 20. First we put 20 as left, we put the 20 left. Now we'll be putting the root 30. So this is the root. Now we'll be substituting 20 30, and then we'll be keeping this 40, the right section. So now we are done with this tree. This tree is called the left tree. We are done with left tree. As we are done with left tree, now we can substitute the main root. As this is the main root here, we can substitute the main root here. So we'll be simply writing 50 here, 50. And then we'll be working with that right tree. As there is right, so we'll be working with that right. So let's start working. So when we come here, it becomes a new root, and it becomes a new tree. We just forget the other entire tree, it becomes the new tree. So notice, when we are here in this section, so that is our entire tree. We have forgotten the left of the part. So now this is the root. And with respect to this root, with respect to this new root, this is the left section. So we'll be considering left section. So we'll 60. And then we'll considering the root 70. So 70. And then we'll be considering 100. So that will be 100. So this is the correct representation how we can represent. And did you notice how we thought like a programmer, like a computer, that we will not stop, we will come here, it is okay. Now again we'll try to understand the same things, because we have to solve the program. So this is 50 first one, and then 30 and 70. 30 and 70, and then 30, 20 and 40, 20 and 40 and 70 to 60 and 100. Okay, and we will check if our program provides us the same solution or not. So what we got after the traversal, we got this traversal result: 20, 30, 40, 50, 20, 20, 30, 40, 20, 30, 40, then 50, then 60, 60, 70, 100. Okay, so we got the traversal. So what we did, first we started with this root node. We started with this root node, and then after checking this was the first root. So we came in this section as per the program that first we have to move towards the left side because that is the logic. First left, then we have to decide the root, then root, and then we have to again move towards the right. So first we will be traversing towards the left, and then we'll again come here. So as per the program, when this is the root, again we will come here. Okay, so this is how we will traverse in the program, that we will come here, 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 again and again, again and again. And now if we just come here, if you go to move, we get null here, null. So we cannot move more forward. So now after null, we're processing the root. So first we have processed this 20. And then once we are done, we'll just move backward, and we'll process the root as told root. So we process the root as 30. And then after 30, we move towards the right side, and now this is the right. When we come in the right side, again there is null, again there is null, so we get null from there, and we just substitute the 40. So in this way the program works. After this side is done, this side is entirely done, we process the root. So we have processed the root, this one, after the entire tree has been done 50. I think you are getting this one. So after this has done, now we utilize this one, it becomes our entire tree, this becomes our entire tree. And now we process, now this tree is the new tree, and this node becomes the new node, this node becomes the new node, it becomes the new node. And with respect to this node, it becomes the left side, it becomes the right side, and it becomes the root, that becomes the root. So first we again process the left side, 60, we have processed 60 because this was the left with respect to that tree. Now again we process the root, 70, and then 100. So this is, so how we can implement in terms of program, that is we have to notice. So we can easily implement in terms of program. So for that we have to implement a method, and we called it the tree order. So let's start. That first we have to first figure out the stopping condition, the stopping condition, that when our program stops. So if you notice, when you encountered null here, every time everything, if this portion is passed, or this portion is passed, or this portion is passed, everything is passed as a root, as a root. So first we will be checking, it stops when you get null. So if root not equals to null, that will be our stopping condition. If, let's change the pen color, if root not equals to null. So this is the first stopping criteria, that if we get null, we will stop the program. If root not equals to null, then simply we'll process. So we will end calling that entirely inside a function, and we'll be calling this function, infinite. So public void, infix, or InOrder, what is that, whatever, so we call it InOrder. And we'll be passing binary tree node, and root will be passed mainly from here. So this is started. So first we process the left side, so we'll be simply in order root dot left. So every time it will call the in order left side, because this is because it is recursive function. So after this recursion has been done, we will be calling the main portion, we'll be printing the root node. So we'll be simply implementing system dot out dot println. What we print, if the root is pointing to this one, So we print the data portion. This is the data portion that we print. So simply root.data, root.data. I think you are able to understand this, or let me just remove this portion. Root.data. Okay. And then we process the write portion. So again, we'll be writing in order root dot write. Okay, and this program will automatically run again and again, and it will provide as a result. So let's see the program. Okay, and we are in the code section. So previously we have already written the same code, and this is pre-order. So right now we are printing in order type. So let's implement the in order. Public void in order and binary tree node root, and then simply we'll be checking if root if root that is not equals to null, the base condition or stopping condition, then simply first we'll be printing the left side, then the root, and then the right. So left, and for that in order root dot left. Okay, now we'll be printing the system.out.println the root dot right portion, right. Okay, and then we'll be processing the in order right portion, root dot right. So now we have implemented our in order, and now let's see if it prints the same elements or not, the same order or not. So this is pre-order traversal. Now we'll just move in order traversal, in order traversal, and tree dot root, tree dot pre-order, not tree dot in order, tree dot in order. Okay, so now it will be printing in the in order section. Now we'll be inserting the same elements. Previously we have inserted 50. Okay, then we inserted 30, 20, 40, 30, 30, then we have inserted 70, then 20, 40, 60. Instead of 18, now we have utilized 100. Okay, so this is 100. Now we'll again compile the file. As in Java, we'll again compile the file after any changes. So Control S to save. Java compile and Java binary tree. So notice, let's look what it provides. In order traversal, Java tree.insert Java binary tree in order traversal null, deleting the 50 after deletion. I just don't get it why we got this null. Let's see in here what the mistake went. Root in order. Look, we have printed here root.write. That means how stupid we are that we printed the address. So we got the address value here. So these are all type of anything's a random address value. We have to print the root.data portion because we want to get the data. Okay. So now again we'll be compiling the file. So that was address what we just got. Java compile, Java. And now again notice. And this is the element in order traversal. So first we got 20, then 30, then 40, then 50, then 60, then 70, then 100. So we got the same order. Let's check. I'll see. Okay, so we got first 20 as you know, then 30, 20, 30, 40, 50, 60, 70, 100. So our program works same. So this is all about the infix operation. So in next video we'll be understanding the prefix operation.